Calculating method detection limit. Deviation, average. Yeah. One, 8, 2, 1. Okay. So then your method detection limit for exchangeable acidity is 0.72, and for aluminum is 0. Right. So if you go to your quality control table, this is all method stuff. Let's see. So 0 here, 0.00 milliliters. And actually, hydrogen is not correct. It should be EA for exchangeable acidity, and that is 0.72 milliliters.
Why was hydrogen not correct?
Good question, because that first titration measures all the exchangeable acidity, right? And the second one measures aluminum. And then the difference between those two is hydrogen, right? So let's see here. We have here titration for hydrogen and aluminum, titration for total acidity. And what I'm going to do right here is after in my caption above the table where it says titration for hydrogen and aluminum, I'm going to just put EA, exchangeable acidity. So I know what that means in my table. All right. Okay. So I'm going to go back to this. And what I need to do then is compare all of my column G's to 0.72, right? And if you look at column G, 0.72 is higher than all of them. So what does that mean for exchangeable hydrogen aluminum according to this method? It's not sensitive enough to measure exchangeable acidity. So these values are all 0. Say there's no measurable, at least that we can measure. I'm not saying that that's true. I'm just saying that we were unable to measure any exchangeable aluminum. Sorry, any exchangeable acidity, hydrogen, aluminum. If we can't measure any exchangeable hydrogen and aluminum, then certainly we can't measure any exchangeable aluminum either, right? So aluminum also is 0. So in our class soils, the Stanislaus, which is actually the Holland soil and the Los Osos soil, those values are 0. What about our standard reference soils? Standard reference soils are here. Right? Is there, by the method that we use, detectable exchangeable acidity or exchangeable aluminum? No, there is not. So those are all zeros too. Okay, we do have some exchangeable aluminum data for SRS 1506 and 1606. Those are the known values there. So there is some exchangeable aluminum. The units that you are seeing there is milligrams per kilogram. We could convert those to centimoles of charge per kilogram, but we're not going to. So in that soil, there is some there. We just weren't able to measure it, which just tells us that the method that we used was not very sensitive, right? That we would, if we're going to do this again, we'd use a different technique to measure exchangeable acidity and certainly exchangeable aluminum. Okay. Okay. So we do have some exchangeable acidity when we get to the Costa Rica soils, right? Because starting here, we have a value of 0.8, and almost all of them, or all of them, are above 0.72, right? So we need to talk about how we're going to measure exchangeable acidity with that titration, and I'll just show you how we'll do that calculation. Okay. Good. So that's just converting our milliliters of titrant, right, which is 0.8, to centimoles of charge of exchangeable acidity per kilogram. And we only have values for the Costa Rica soil. We're missing one here because I think it was over titrated. So I just converted that to 0, or I just deleted it, got rid of it. And then, yeah.
Are we able to get the aluminum in magnesium in the Costa Rica soil? Because there's just like, that soil just has so much aluminum, it's highly leached.
Good question. It's a very good question. Yeah. So our technique is not very sensitive, right? And in the Los Osos soil and the Holland soil, the quantity of exchangeable acidity is relatively low or lower. And so we weren't able to detect it. And it's there, but we weren't able to detect it, right? We know that it's there because our standard reference soils have some exchangeable aluminum that we weren't able to detect, and they have kind of similar weathering patterns as the soils that we used in class. Okay. So Costa Rica, though, pretty highly weathered environment. I would imagine that our soils, right, are ultrasols or oxasols. And so we just have appreciably higher quantities of exchangeable acidity. And because of that, we're able to detect them. So now we need to talk about exchangeable aluminum. Okay, it's a similar titration that we'll go over on the whiteboard, and then we'll plug it in. Okay, we'll convert milliliters of HCl to centimoles of charge of aluminum per kilogram. Times 100 divided by. Oh, I messed up, didn't I? I totally messed up. Sorry about that. You probably saw it. Mia, what did I do? What did I forget? 5. Messed up on 5. I forgot 5, even up here, right? So we got 5. Got a 5. Cancel out, right? And I got a 5. 5. Right? So cancel out. So instead, this is whatever that difference is times 100 divided by all that. And this is just the difference between those two. You know? Right, because everything else cancels out. Sorry about that. So go back and recalculate your exchangeable acidity. That was a close one. Just the difference between those two. Barely any exchangeable aluminum. Oh wait, I messed up on that formula too. Yeah. I did. Yeah, I missed something. It's better. Close one. All right, do you see that we have a little problem also? See our problem here? So we have more exchangeable aluminum than we have exchangeable acidity, which doesn't give me a lot of confidence in our determination of aluminum. So my assumption then is that these titrations are off, right? Where we have those negative numbers, those titrations are off because I can't reckon that. Oh, I'm just gonna get rid of it. Okay. So that calculates the total quantity of exchangeable hydrogen and aluminum, total quantity of exchangeable aluminum. You all good with that? I assume that that is a yes. Yes. Yeah, for exchangeable aluminum. Yeah. So for this one, we'll do it here. So for Costa Rica, actually, where did we start? Here. No. Yeah, Costa Rica, number 4. You see that? Yeah. All right. So over here to the side here, we have our percent relative standard deviations of exchangeable acidity, hydrogen and aluminum together. And the values that we want to focus on are the ones that we actually have numbers for. So they're those ones. So they range from 21% to 54%, right? That's our percent relative standard deviation for exchangeable acidity. Okay, so I'm going to put that into my table here. So for table 2, percent RSD for exchangeable acidity is 21 to 54. Pretty poor, right? Precision. Which, when you're not measuring much of something, when you're measuring something that's close to the detection limit, usually your precision is pretty bad, right? And we're close to the detection limit. So that's why our precision is not so good. For exchangeable aluminum, here's what we could do for these same values here, right? So I plugged in the formulas for us. I'm not including any of the data where we don't have values, right? Because those won't give us anything, but I'm just going to take these values here, right there. Can you see that? Those ones. And I'm just going to pull it to the right. So I can go down here and pull it to the right. That's going to copy those formulas and apply those formulas to the column just to the right. So this is for exchangeable aluminum. All right, so for exchangeable, it should anyway. So let me check to make sure. So it should be K19 to K21, yeah. But why am I getting this? Oh, because it's just 0 divided by 0. Okay, so here for exchangeable aluminum, we're getting 0 to 11%. Yeah. Yep, we are, because, good question, Kylie, because we ran these with everything else. So for aluminum, percent relative standard deviation is 0 to 11. For percent recovery of SRS, for let's see here, for exchangeable acidity, we don't have a number, it's just Na. But for exchangeable aluminum, we do, and it's 0. That is to say, remember, we in our SRS 1506 and 1606, we didn't measure any exchangeable aluminum, but there is some. If we go back to the spreadsheet here, right down here, here's the quantity of exchangeable aluminum there. And for SRS 1506 and 1606 down here, we didn't measure any exchangeable aluminum, right? 0. So it's just 0 divided by the known. So 0. So that's just not good. I mean, it is what it is, right? We're doing this so that we know how good our data are, right? And how confident we can be in our values. And we don't make up stuff, right? That's the point. I'm not making up stuff. All right, good. Okay, so total acidity now. Are you all doing good? Yeah. Okay, let's talk about total acidity. Oh, before we talk about total acidity, let's go back up here. So for hydrogen, aluminum, total acidity, and ammonium, and this is for the instrument quality control, we don't have any values for instrument quality control for those titrations because everything was done at the method level, even for the ammonium. We do have R squared for the calibration for nitrogen on the carbon nitrogen analyzer, and it was 1, but we don't have anything for anything else. So there's no point in displaying that because it'd just be all NAs. So I'm going to select it and just get rid of it and delete it. So that table is completed, and our method quality control table is almost completed. All right, let's go to the barium chloride USDA CEC barium chloride TEA total acidity. And here, right, here we have the sum of exchangeable cations from the ECEC method right here. They've already been populated for us, which is wonderful. And we have the milliliters of titrant that was required to completely neutralize what? What were these? What was the hydrochloric acid added to completely neutralize? Certainly it wasn't added to neutralize the acidity because it's an acid. Triethanolamine, right? The unneutralized triethanolamine. So what that means is that we got to go to our blanks, right? Here's our blanks down here. And we need to figure out what the average, we're not going to figure out a method detection limit because a method detection limit is used to determine the lowest quantity of something that we can analyze. And this is telling us the highest quantity of something, right? So we're just going to figure out what the average of those 10 blanks was for triethanolamine. And then that's going to be our starting point. We're going to subtract the milliliters of 0.2 molar titrant that we added from that. So just calculate the average of just your blanks. And if you're like me, it should be 3.97. So that is the value that is, we're going to start with that and subtract the milliliters of titrant that we added from that to figure out the total quantity of acidity. And the way that we're going to do that, I'll show you the calculation now. It's pretty straightforward relative to determining exchangeable acidity and exchange. Okay. At 3.97 minus that times 5. Then we fill it down. And like the last one, it's got a problem, of course, right? Because it's a negative number. So I'm going to get rid of it because it doesn't make sense. And then this value 2 here is off also, right?
Yeah.
Okay. That value is messed up because the total acidity value is messed up. So I can't trust it. Well, yeah, because like we can't have a negative quantity of total acidity. It just tells me that that titration was incorrect. That's why we do duplication, right? That's the point. All right, you good? So now, right, we have our formulas built in for percent relative standard deviation, and we just need to look at the range of these. And I'm seeing 2 to 41%. That can't be right, can it? I guess it is. Okay, 2 to 41%. That's total acidity, 2 to 41%. Method detection limit, we don't have that. And SRS, we don't have that either. Okay, now we need to go to the UNFAO. And you want to take a break for 5 minutes? All right, let's take 5. Sites, right? So we have our ammonium saturated quantity of percent nitrogen and our just soils that didn't go through the procedure quantity of nitrogen. So that's just what our soils have on them inherently. And we're just going to subtract them to get our saturated minus unsaturated quantity of percent nitrogen. And what that will tell us is the quantity of exchangeable ammonium, right? Or as a proxy for the quantity of exchangeable ammonium. So I did, yeah. So I just sent you another spreadsheet. This is the latest one. So my suggestion is to close that other one and just pull up this one and work from this one. And then subtract ammonium saturated N from unsaturated N and then fill that down. And then we need to convert that to a quantity of CEC. And it's like a pretty cool little calculation. Okay. Thousand divided by the atomic mass of nitrogen. That
What's the range in average values for CEC?
what do you mean?
Like between like different like kinds of soils, like what do you naturally get that?
Oh, good question. So the question was, what is like are some good normal ranges of cation exchange capacity? So of course it depends upon the method that you use, but like a soil that's got, let's say it's a temperate region soil that has 10 to 20% clay in it, that should have a CEC of like 15 centimoles of charge per kilogram to 20. A very clay soil, so let's say the Los Osos or Diablo soil, it has 40% clay and it's mostly like smectitic clay. That'll have a CEC of 25, 30. A tropical soil, which has 50% clay, will have a CEC of it's mostly kaolin, iron, and aluminum oxides. What's the CEC of the Costa Rica soil? Oh, those are kind of high actually. But should have a value of like less than 10, right? Because the types of clay, right? The types of clay are ones that don't have a lot of permanent charge from isomorphous substitution, right? They're mostly charge that's resulting from changes in pH or variable charge. So notice that the SRS, or sorry, the percent relative standard deviation has been calculated for us, right? You know the formula for that. It's just the standard deviation divided by the mean times 100%. So we just want to report the range there. And the range looks like it goes from 2 to 17%, if I'm looking at it properly. So that's pretty good. 2 to 17%. Let's see. We do not have an MDL for that. And For percent recovery of SRS, we do have that. And that is given by these values here. 65 to 88. So the exchangeable the exchangeable UNFAO CEC was 8.9 and 21.2. We got 5.78 and 18.56. And so our recoveries are good for the 1606 and not that good for the other one. 65 to 88. Then that table is complete. Right, that's nice. So let's make these tables look a little bit better. Are you ready to do that? You good? Okay, we're just gonna make these look a little bit better. And generally when you look in a journal and look at tables, they don't have all the grid lines. So we're just gonna get rid of most of those grid lines, and I'm gonna select that table all together like that. You can do it several different ways. And when you do that, you'll see this box that comes up, and we're gonna focus on the borders. And we're gonna get rid of all the borders first. And then I'm gonna put a border at the top and at the bottom. You also have a border menu on your home screen too. Do that. Bottom. Then I'm gonna put another one down here. And then another one right here, across there, top one. So should look like something like that. And you can do the same thing to the one below it, right? Just make it look like that. Lovely. Okay, let's go back to our data sheet. So this will take us or get us to the point where we can put everything in a jump and have jump create some figures for us. So if you go to JMP format 2 tab, you'll see that all of our data have been populated. And the soils have been named appropriately, finally. So we got soil in column D, method in column E, and then the CEC determined in that soil with that method in column F. Okay. So that's all good. And we're only, this experiment and this report that we're writing up is only considering the Holland and the Los Osos soil, the A and the BT, SS for Los Osos and the A and BT for Holland, right? So we're not gonna do anything else right now with the Costa Rica soils. Before we do any manipulation with these data here, what I wanna do is I'm gonna copy this spreadsheet, and I'm gonna manipulate the data in another way so that we can do a correlation between the methods with each other. So we're gonna correlate the ECEC method to the other two methods and see what their relationship is like. Okay, so the way to do that, if you know how to do it, you can do it, but you can right click on it and you can go to move or copy. And then you check the box for create a copy, and I'm gonna put, it says before the sheet, and I'm gonna just put it before the sheet 2016 summary CEC figure. So now I have a JMP format 3. Now I want to point this out to you. So if you click on cell F2, you'll see that that cell is linked by a formula to the cations for ECEC data, right? We're going to move these around, and if we move them around, then that's going to change the formula. So what I want to do is just copy this column of data and just paste the values. Okay, so I'm going to go to column G or column H, doesn't really matter. Here, I'm going to say for paste options and go to the one that says values here. Okay, so that'll do that. I'm going to delete these because I don't need them anymore. And then what I'm going to do is just organize them by method. So I'm going to have one column for ECEC, another column for UNFAO CEC, and a final column for USDA CEC. Okay, so in other words, I'm going to call this ECEC. And then I'm going to take my UNFAO CEC values, which are these ones, and drag them up here. So these are UNFAO CEC. And again, the reason why I'm doing this is so that my data are in a way that are organized in a way that JMP can work with them. And then USDA CEC. Okay, so you should have something that looks like that. All right, I'm gonna save it. And what I'm going to do is I'm going to create an XY plot. X is going to be ECC and Y is going to have the UNFAO and the USDA CEC values. And I'm going to create a linear relationship between them and see how good that relationship is, right? By having JMP calculate a R-squared value and plotting the equation of the line, and then also giving me a p-value for that relationship. Okay, so go ahead and open up JMP. And it might give you a tip. And what we're going to do is go to File and then New and Data Table. Okay. So this is like, we finally have all our data. And now we want to create some figures to summarize our data, right? Because looking at like columns and columns and rows of data is not that interesting, right? It's much better to create some kind of visual to help us observe trends in the data. And so that's what our job is to do now. So from here, I'm going to go back to my spreadsheet, my Excel spreadsheet, and I'm going to copy the data that I want. So I'm just going to copy those data right there. Go back to JMP and go to Edit, and the option would paste with column names. Bless you. Okay, so once you've pasted with column names, all your data should be in. And on the far left, where it says columns, you'll see that you have ECEC, UNFAO CEC, and USDA CEC, and then you have those blue triangles that are next to them. That tells you what kind of data you're looking at. When it's the blue, it is numeric data. Okay, and I'll show you if it's words, like if you have a variable like soil in there, then it'll be red. Okay, but to check, you can double click on any of the column headings. So I'm going to double click on ECEC. You'll bring up this. And if JMP imports your data incorrectly with an incorrect format, you can change it here in this drop down box, right? You can change it to character if it's character data. I'm going to keep it as numeric and it should be continuous. And I click OK. Okay. So then we're going to go to Graph Builder and create a graph, XY plot. So we'll go to Graph Builder, and I'm going to put ECEC on the x-axis and the UNFAO-CEC and USDA-CEC together on the Y. So there's ECEC, and then I'm going to select UNFAO-CEC and USDA-CEC together by holding down the control key and clicking each one. And I'm going to drag them to the Y. Should have something that looks like that. And I don't want like the squiggly line. I want a straight line because I'm trying to model these with a linear function. So I'm going to select the linear model here. And you should have something that looks like that. Okay. Are we all there? Yeah. Carolyn? No surprise. So if you get rid of the fit, if you uncheck fit, that'll get rid of the lines that are, or the fit parameters. That just tells you the spread of your data around that line, around the linear model. And what we do want to put in those R-square value, the equation, and the F-test. So the R-squared tells you how close your data are to the straight line. R-squared of 1 means that your data points fall on the line. The p-value, the equation tells you y equals mx plus b. And in this case, they do y equals b plus mx or minus mx. If your slope is 1, right, that just means that your values equal each other. Right? That is to say, whatever your ECEC is, that's your UNFAO-CEC or your USDA-CEC. And we see that that's not the case. Right? And for solving for ECEC, we can see that our slopes are less than 1, right? In both cases, which just tells you that the ECEC value is always less than those other two methods. Yeah, so the F-test tells you the significance of the relationship by putting a p-value on that relationship, and a significant p-value is it depends, but you've seen like where you maybe in peer-reviewed literature, you've seen R-squared equals some value, and then they'll put like asterisks, 2 asterisks, or 3 asterisks. You've seen that before? Okay, so 1 asterisk means that that relationship is significant at 0.05, 2 is 0.01, and 3 asterisks is 0.001. Okay, so all R's are 3 asterisks. That is to say the R-squared is significant to more than or less than 0.001. Okay, so what we want to do now is just format this a little bit better. And the first thing I'm going to do is I'm going to drag my values in, or my legend in, to the figure. And I'm going to adjust this a little bit, but you can drag it anywhere you want. I'm just going to put mine there. And then what I'm going to do is right click. So generally, wherever you are, if you right click, that'll enable you to format that area. So I'm going to right click in the center of this and go to edit, I think. No, I'm going to go to show properties. I go to show properties. It's going to bring up this box over here. And the box over here allows us to set the background color and the text color. And I always like to set the background color to white. So I'm just going to click in that box there and make it white. And then for text color, I like to make my text black by default. So I'm going to click in that box and change it to black. And then you can get rid of that box that we just brought up by clicking on the X, the red X. We're gonna create a caption for this, Liz.
Like for the legends. and-
Oh, here? You don't have, do you have these dots though? Okay, so you have those. So we'll talk about how to fix that right now, actually. So if you double click in your legend, you'll bring up this right here, and then we're gonna what do you think is better? Dots or lines? We don't need both. You like lines better? Okay, so uncheck the dots. You have them. And also, you'll notice that which is on top, USDA CEC or UNFAO CEC? USDA. So I'm going to click on USDA right here and bring it up one, so that when you're looking at it, it's above it. I'm going to change the font size also. I'm going to click on that font box and I'm going to make it bold, and I'm going to make my legend entries 14 point. And then click OK. There we go. That's better. And then what I want to do is I want to change my axis headings. I'm going to make those bigger and bolder. And I'm going to change my axis labels to be bigger and bolder. So I'll just show you on the ECEC, and then you can do the y-axis, or I'm going to do the x-axis, you can do the y-axis, okay? So I'm going to just click in ECEC, and then I want to include the units always. So the units are in parentheses, they're centimeters of charge per kilogram, close the parentheses. And then I'm going to, you see how the cursor changes from an arrow to like a hand? You right click on it when it's a hand, it should enable you to bring up this box right here. And we're going to change the font. You see what I did? Show you again. So I got the black arrow, and I'm going to put it right over the legend, or not the legend, but the axis label, and it turns into a hand. I'm going to right click and go to font. And I'm going to make that 14 also in bold. And then for my numeric data here, notice, so I want to change that. So now I got my black pointer, right? And if I go into that area, it makes it a palm again. So I'm going to right click there and then go to axis settings. And I'm going to change my font. And this time I'm going to make it 12 and bold again. And click OK. And click OK. And then you just do the same to the y-axis. And then the last thing that I'm going to do is get rid of the title, because like I said, we're going to make a caption. So I just select in there and delete it. So I'll give you like a minute or so to do all that, and then we'll talk about the next thing. How'd I get it? Like this? Do you have this?
No.
You don't have a legend. Okay, I think, bless you. I think if you right click inside of it, think where that legend entry is. Anyone find where the legend is? You're missing your legend. So Marco, you're missing your legend and you need to add a legend. All right, let's see here. I don't know. But if you like just do a Google search, put in JMP, insert legend, like JMP graph builder legend.
Oh,
Tyler, where is it? Oh, so he's got it. Oh, okay. Yeah, you just drag it over. I'm sorry, I misunderstood. All right. So go back to your jump spreadsheet, right? This right here, and save it as something. Whatever you want, but put it in a place, of course, that you're going to know where it is. And then once it's saved, go back to your graph. And where it says graph builder and you have the red triangle, you click on that and go to save script. Save script just allows you to save exactly what you've done here so that you can come back to it later if you want. And I'm going to save it to the data table. And it'll just say graph builder, and you can leave that title if you want to, but you don't have to. You can call it something else. You can call it like XY plot. Click OK. And then what we want to do is we're going to export it. So to export it, you go to File. You could also save as, but I'm going to go to File and Export. And I'm going to export it as an image. You can do PDF too if you want. I'm going to change the format to JPG. You can work with whatever format you want and click on Next. And then it's going to ask you where you want to save it. You pick wherever you want to pick. And it may open up like a picture viewer for you. And there's just like a quick thing that we want to edit it to crop out this stuff up here. So I'm going to click on that edit thing right here. If this doesn't come up, you can edit it in some other, but I'm going to crop it. So I can click on that crop button. I'm going to move that. I will get rid of that and then crop the side a little bit like that. And then I'm going to I don't want to save a copy. I just want to save it. All right. So now it's ready to go. Okay. Nice. So I am going to X out my graph builder for this. And notice that in my spreadsheet here, I have this right here on the top left, and it says the XY graph. It might say graph builder for you. If you click on that, it'll open up the graph that you just made. So it's appended to this spreadsheet. So it's there if you want to get it again. Or if you edit it, then you need to save the script again and append it to the worksheet so that you can access it. Okay. So that's the first graph that we're making. It's just relating and showing us the relationship between the ECEC measurement of CEC and the other two, and we notice that there's a strong relationship, right? Where one's low, the other's low. Where one's high, the other's high, right? And so that's what we see, that they're well correlated, which we would expect them to be correlated, right? So the next thing that we need to do is, if you go back to, and actually I'm going to close this worksheet too. I'm just going to X out. Save changes, yes. So now I'm just back to this. I'm going to go back to my Excel spreadsheet, and I'm going to go to the JMP 2. And what I want to do, or what I'm going to do, is create a figure that looks like this. So it summarizes everything. All right, so what this is showing you is soil and method as they are changing as a function of CEC. And then we also have the statistical data of the ABCs and stuff. And what that tells us is that at a p-value of 0.05, where you have the same letters, those CEC values are the same. And where the letters are different, they are significantly different. Okay, so we're going to create a summary figure just like this. I created this one in Excel a few years ago, and it took me a long time to do this. And so we're just going to see how Jump does it, because Jump does it fast. So we need to go back to the spreadsheet that has our data, JMP2, and we're going to copy our data that has soil, method, and CEC just for the Holland and Los Osos. Just select those data and copy it. JMP format, parentheses 2, and then go to Jump, and then go to File, New Data Table, and do it like we did before. I went to Edit and Paste with column names. Yeah. So notice over here on the far left that you have some character data and numeric data, right? We know it's character data because we have the red histogram, right? And that tells us character data. When we have the blue triangle, that tells us it's numeric data. So it's going to be analyzing soil and method as character data, and then the CEC as actual numeric data. Yeah.
If we pasted it and it didn't come up with the file names and the column headings, how do we undo that?
Okay, so what you could do is just do it again, or you could double click up here, like double click up there. And when you double click up there, you can put in soil and then character and nominal and hit apply. But if you wanted to do it again, you could just exit this, not save it, and then go back here, copy these data again, and then when you go back here, go back here, you can just try and do it again. And when you go New Data Table and paste them in with column headings. Maybe that didn't work for some reason. I don't know. All right, so let's save this first because we didn't do that last time. That's the first thing we should have done. So we're gonna just create a graph like we did before using the graph builder tool. I'm gonna go graph builder. On the x-axis, I'm gonna put soil. I'm just gonna drag that here. On the y-axis, I'm gonna put CEC here. And see where my legend is over here where it says CEC dot or dot CEC? I'm gonna drag method over there to replace it. So I'm gonna take this and just drag it over here. And then I'm going to create a histogram by clicking on the histogram. Right, and then I'm going to take my legend and drag it in there. Just like we did before. Your summary statistic is mean, which is what we want. We want an error interval. And so we're going to click where it says auto because it hasn't put anything in. We're going to put standard deviation. So we'll put in our standard deviation bars. That should be fine for now. And then what I like you to do is do the same things that we did before. So we're going to get rid of our title up here. I'm going to right click inside and show the properties and change that to white for my background and black for my font color. And then I'm going to change the font size of my axis numbers and my axis titles or labels. And I'm going to change the font size of my legend. Okay, so you guys just go ahead and work through that, just like you did before. And when you change your y-axis label, rotate it to the left. Yes, Lee.
How again do you rotate the y-axis?
If you put that cursor over it like that and then right click on it, it should say rotate text.
Oh.
So that is a good way to summarize all the stuff that we did, because we can see very easily that, for one, Holland soil has a much lower CEC no matter what the method is compared to Los Osos. We can also see that there's like a stair-stepping trend where UNFA or ECEC is always the lowest, no matter what the soil type is. UNFAO CEC is next, and USDA CEC is always the highest, right? And so when you are writing eventually your results and discussion, right, you're going to summarize your findings by relating to or referring back to this figure and talking about what you observe and then why, right? So why is ECEC always the lowest? Why is UNFAO CEC the next highest and USDA CEC is higher than that if they're statistically significant from each other? So that's the next thing that we're going to do. So we're going to do a significance test between those population means. Okay, so to do that, we're going to go back to our data here, and we're going to do a fit model test. So if you go to analyze, and we're going to fit a model this time, and our response variable is what? CEC, right? Whatever's on the y-axis, that's our response. So I can click on it and drag it in there, or I can click on it and click Y. I'll put it in the response. And then for the model effects, it's the other two variables. So you can select them one at a time or together by holding down the control key and clicking add. But we don't just want them separate as soil and method. We want them also together. So I'm going to click soil and method and go to cross. You should have 3 entries for the model effects, soil method, soil times method. Yeah, you go. For sure. Okay, so I'm going to go to analyze, fit model. My response variable is CEC. My model effects are my other variables. So I'm going to add those by clicking. I can click on them to select them, add them down here, and then I'm going to cross them by selecting them together and clicking cross. And then when you're done with that, you're just going to run the model. And you're going to see all these different relationships. You see the entire model. You're going to see the soil, the method, and what we're really interested in is the soil and the method test. And we want to compare each population mean to each other. There's a lot of different ways to do that. You remember one of them called Tukey HSD. So that's the one we're going to use. So if you click on that red arrow next to soil times method, you can go to LS means or least squares means Tukey. Click on that and you'll pull up this table, which is complex and difficult, but what we're really interested in is those letters there. So if I go here to LS means differences HSD and click on that red arrow, I'm just going to get rid of the crosstab report. And the crosstab report is what's immediately below it. So now I just have those letters, the connecting letters report, which is what I want. Before I do anything else, though, I'm going to save this by appending this model to my spreadsheet. So response CEC, I'm going to go to save script to data table, and it'll just say fit least squares so that I don't have to, it didn't take long, right? But we already did it. So I'm going to append that. Next thing that I'm going to do is I'm going to go to my LS means Tukey's differences and click there, and then go to save connecting letters table here. So I'm just clicking on the red arrow and it'll open up that. So this is what I'm going to use now to put in another row or another column of data in this spreadsheet here. So in other words, I am just going to take these data here and make a column that's called label. And it's going to be character data that's continuous. Sorry, character data that's nominal. I'm going to apply that. Click OK. So here's what I'm going to do. I'll give you a minute. So what I'm going to do is I'm going to put in my letters that are associated with each of those populations. That way, JMP will recognize that as my label column, and then it'll put in those letters in my figure. It'll make sense when we do it, if it doesn't make sense when I'm speaking it. So here's what I'm doing. I'm going to take Holland A, ECEC. I'm going to look for it here. Here's Holland A, ECEC, the letters H. So for my label here, I'm going to first click on the caps lock on my keyboard, and I'm going to call these all H. For Holland BT, ECEC, I'm going to do the same thing. Holland BT, ECEC is GH. So I'm just going to put in GH in all those. For Los Osos, A, ECEC, same, right? Look at your connecting letters report and put in the appropriate letter. And then we need to tell jump to label this. So I'm gonna click in that column and then right click. And there's a option to label and unlabel. And I want to label. And if you do that right in the lower or in that left hand area, it'll be label has a little tag on it. So I was just telling Jump that that is going to be our label for our figure. Okay. Okay. Go to your figure now. And where it says label and there's no labels, you can click on that drop down. And we want to label by row. And then see how some of them are kind of low and they're hard to see. So you can click on them and drag them up. And everything that I did today, I mean, it's being recorded and it'll probably like bore you to death to watch it and listen to it, but like you can speed it up, which is a nice option. But you can also just like do searches on YouTube, and most of these things have been done by somebody else and they recorded it to YouTube. So that's always an option. And I'm going to save the script again. And then do the same thing, right? Export it and save it like we did before. Yeah, Lee.
How do you open up the graph builder?
How did I open up the graph builder? I just hold down the Alt, and then if I'm holding down the Alt key, I hit Tab, and that'll go to all my windows by clicking on the tab.
No, I lost the window.
You lost the window? So if you just open up that graph again, oh, you go.
What?
But you jump into the designer time.
All right, you good? Okay. So R is another tool, right? You can use. A lot of faculty in our department use R because it's free, right? And you can use it even after you graduate from Cal Poly. Cal Poly has a license for the software, and so it's free for us. But once you leave Cal Poly, you won't have the same access to it. But I use it because it's easy. So we've summarized our data. Let's shift gears now, unless you have any questions about what we've done, and talk about the resubmission of your materials and methods in introduction section. Do you have any questions about this? We will revisit the data when you get ready to turn in your results and discussion and conclusion, but that'll come up next week in the lab and the activity. Okay. So the group, let me stop recording this.